Okay, it says find the volume of the area between y equals x. Whoa, wrong problem. We already did that one. We move forward to example 3. We have 2 problems to do today, and then second hour, 20 minutes to work on their assignment. Like I said, for a lot of people, that was 20 minutes for fortnight. Find the volume of the area bounded between the curves x plus 2y equals 6, x equals 0, y equals 1, rotated around y equals -2. Does anybody see, by looking at this, what's automatically different about the problem compared to what we covered before? Very good. So it's not the x or y axis, okay? The z axis, okay? Yep. That'll be multivariable calculus. So that'll be kind of Calc 3. We're not working on it yet because our clientele is not intelligent enough yet to handle that. Scared, I'm petrified. Terrified, stupefied by you. All right. All right, I'm going to grab x plus 2y is 6. What shape does this make? Makes a line. What's the x-axis or x-intercept? 6. What's the y-intercept? 3. So I'm going to graph this. So I've got the first line figured out. What does x equal 0? Yep, that's the y-axis. Thank you, Gina. And then what is y equals 1? It's the horizontal line, y equals 1. So that's my area. Is everybody convinced that that's the region I'm working with? I want to rotate that around what? Y equals -2. So you're going to spin this around that. If you want to try to draw the shape, you can see that you're 3 units from the bottom, right? And 5 units from the top. So if I go down 3 more, 1, 2, 3. So I guess I could be the 3 units to the bottom, 5 units to the top. What do you mean? Yes. So Jake's question is, could he do the same problem? But what he would like to do is he would like to, instead of revolving around y equals -2, he'd like to revolve it around the y-axis. And in order to do that, he wants to take this shape and he's going to shift it up 2 units. That's fine. So you would need to actually, then change the equation. So if you want to do that, then that's fine. Okay. This is my shape. If I want to find, kind of a volume here, what I'm going to do is I'm going to choose to draw this vertical rectangle. And as I spin this around, you can see it's going to be the inside of my washer. There's the outside of my washer. Everybody convinced I get a washer shape? Okay, what's the thickness of your washer? Very good. Thickness is dx. So I'm going to draw a smaller version of that washer. makes up the inside of the washer? Or what makes up the rotation? Y equals -2. What makes up that inside portion of the washer? Y equals 1. What makes up the top portion of the washer? Okay, so what Andrew did is he decided, since it's dx and everything is y equals, that he should solve this equation for y. So he subtracted the x, divided by the 2. You got y is equal to -1/2 x plus 3. And he's 100% correct to do that. So as we look at this, we can identify what little r is. What is little r? Little r is 3. How did you get that? Good. You thought of the difference between the two. So a lot of people think of that a different way. Let's just be clear. You did top minus bottom. Everybody agreed? Top minus bottom? Okay, so 1 minus -2. That gave me 3. So what's the big radius going to be? Yeah, -1/2 x plus 5. So you have to subtract the -2. Everybody golden? Okay. The formula for the volume of washer is pi times big R squared minus little r squared. So in this situation, I will pi times -1/2 x plus 5, that quantity squared, minus 3 squared dx. That's the volume of one washer. How many washers do I want? Infinite number. We accomplish that very simply in calculus by using the integral symbol. Now I need to figure out my bounds. A lot of people get confused about the bounds and how to determine them. We look at the original area, folks. This is the original region that we are rotating around. And because the thickness is dx, I consider the horizontal portion of that region. Where do I start? Start at 0. And then I go to this coordinate right here. Now, we know the y coordinate is what? 1. If we would plug 1 into the equation for the line, we get what for x? 4. So 4 is the x value of my bounds. You see how that's big R? Minus little r dx. It's -1/2 x plus 5 because we do the top minus the bottom in order to get that distance. Is that better? Good question. Any other questions? Okay, let's express this a little bit nicer. We got pi integral 0 to 4. Let's square the -1/2 x. What do you get? Yep, x squared over 4 plus or minus, we'll see how it turns out. We got a -1/2 x times 5 and then -1/2 x times 5. So -1/2 x times 5 would be a -5/2 x, right? And we're going to have that twice. So it'll be a -5x. Okay. -5x. And then you square the 5 and you get, and then you subtract 9. So 16 dx. So that's the setup. Now we just simply take the antiderivative. What's the antiderivative of x squared over 4? X cubed over 12 minus 5x squared over 2 plus 16x. Evaluated 0 and 4. No worries about the 0 because we'll get 0. But the 4, plug in 4, and we get, let's see, 4 cubed is 64 over 12. Each is divisible by 3, or I'm sorry, by 4. So we get 16 over 3. So pi times 16 over 3 minus. All right, plug in 4. 4 squared is 16 times 5. 80 divided by 2, 40. Plus, and then 16 times 4, 64. 64 and negative 40 make 24. So we have pi times 16 over 3 plus 24. Well, 24 is the same as 72 thirds, right? So 72 thirds and 16 thirds will be 88 thirds. So 88 pi over 3. There's the answer in all of its glory. Because you're amazing, Kelvin. Okay? Tell me something I don't know. Okay? So, means the volume of that shape, the volume of, if we were to do all these pieces here and rotate them around, okay, be pretty much hollow at the top. Yeah, the entire volume of the entire shape. Now, if you were to stack all those washers up side by side by side by side by side, 88 pi over 3. Okay, our last example. Super easy. Do you recognize this problem? Where do you recognize it from? This was an AP example problem we looked at. We found the area of region R. Do you remember how we found the area of this region, what we did? Area bounded between two curves. And so in order to find that area, we did top minus bottom. The top function was f of x. And the bottom function was g of x, dx. And we carried our bounds. We said that this spot was 0. So we started at A. How did we find B? Yeah, we found the intersection. So I'm going to use a calculator because we're going to have to do that anyway. Take out my calculator. I've got these two curves right here. And I'm going to take this one off. And I'm going to look at the graph. And does this graph look like that general region that we have right there? Is that kind of what we got? Yeah, so I want to find this intersection point. Looks like it's somewhere around 1. So I could calculate number 5, intersect, and we'll get this written down to a few decimal places. And we get 1.1356, 1.1356925. So therefore, the area became the integral bounded from a to b of f of x minus g of x dx. Is everybody okay with that? So at that point, we just plug in our calculator, right? Okay, and we did that problem together. But let's do b. So b is the big part that we want to focus on. We're not ready to do c yet. C's a lot more complicated. But it says find the volume of the solid generated when r is revolved about the x-axis. So this solid right here is going to be revolved around the x-axis. So are you going to get disks or washers? Washers, aren't you? I mean, you're going to take this region right here and revolve it around. We do know how far away it is from the x-axis. It's g of x away. I wasn't trying to roast him. I was just trying to. Okay. So let's point out what we have here. We know that the volume of a washer is going to be pi times big R squared minus little r squared. And is this dx or dy? This is dx. And the work I'm showing you guys, the AP people would love to see you show this work. I mean, this is exactly what you would write down on the test. Okay. So what's the middle of this portion right here? Y equals 0. What makes up this portion of the washer? Y equals g of x. And what makes up the top portion of the washer? So can somebody tell me, what is your big radius? F of x. So I take f of x and I square that. Minus what makes g of, or what makes little r? G of x. Take that guy and I square it. Dx. So that's the volume of just one washer. How many washers do you want to do? Easy to do infinite. We just slap that integral in there. What are our bounds? Make it easy. A to B. That will give you 2 points on the AP exam right there. Okay. The problem's worth 9 as a total. Part A would be worth 3. Part B would be worth 3. So for part B, that will give you 2 right there. All we need to do now is type that into our calculator, don't we? So we'll be able to finish this before the bell goes. Watch how easily I can type this in a calculator. I'll delete it so we can kind of see all the parts. But I have f of x, which is y1, correct? So I'm going to include the pi, parentheses. I have y1 squared. So variables, y variables, function 1. And I square that. Minus my second function, vars, y vars, function y2. And I square that. And I'm going to take off these first 2 functions so that they're not graphed. I check out the graph here. I'm going to calculate number 7. So here we get a graph. Obviously, it doesn't look the same as what we have because we didn't type in the functions. We typed in the integral for the washer. And my lower limit is what? 0. What's my upper limit? You guys tell me 1 point what? Like that? This is just so cool your calculator does this. Awesome. 4.266. And if you come up with that, that will give you them the 3rd point. So that's really not that challenging of a problem, is it? Come back from lunch smarter. Thank you.